Section 2.6. Let me remind you that we already have cheat sheet number 2 with substitution property, reflexive property, symmetric property, transitive property. We're going to be using that again. Cheat sheet number 3, you don't really have to turn to that just yet. I'll talk through some things. Everything on cheat sheet number 3 is definitions. They're all geometry, terminology, definitions, and because they're definitions, they're all biconditionals. They all have if and only if in the statement. For example, definition of congruent. So you can call these all definition of congruent. Two segments, or we could say angles, are congruent if and only if they have the same measure. Yeah, that's an abbreviation for if and only if. Two segments or angles are congruent if and only if they have the same measure. Reminder on the biconditional means you could say if two segments are congruent, then they have the same measure. Or you could say if two segments have the same measure, then they are congruent. Works both ways, which is why it's called a biconditional. Most of these definitions you already know. A bisector divides an angle into two congruent segments. A midpoint divides a segment into two congruent segments. Two lines are perpendicular if they intersect to form right angles. You know perpendicular, here's the accurate or specific definition for perpendicular. Complementary, if the sum of their measures is 90 degrees. Notice that only works for two angles. You can't have a combination of more than two angles. Two angles are supplementary, if and only if the sum of their measures is 180 degrees. So really not new information for you here. An angle is a right angle if and only if it measures 90 degrees. Notice that's different than two lines are perpendicular. When you're talking perpendicular, you have two lines that intersect to form a right angle. What's a right angle? If and only if it measures 90 degrees. A straight angle, if it measures 180 degrees. And two angles are a linear pair, if and only if they form a straight line. So all vocabulary that you've seen and used before in Chapter 1 and Chapter 3, just now we're going to use it formally in definitions. They're all pretty self-explanatory. The first one you have to be very careful of because congruent and same measure is so closely related that you might think, I already said that. It does say congruent. But notice how it says two angles, I'll use angle this time, are congruent. So you could say if two angles are congruent, if angle A is congruent to angle A, then the measure of angle A equals the measure of angle A. That's a technicality, but it is a legitimate, real technicality in geometry. You have to know that if you're talking about objects, you use congruent. If you're talking about how big those objects are or what their measure is, you use equal. Same thing with segments. If I get these out of here, same thing with segments. If you said segment AB is congruent to segment CD, if two segments are congruent, then they have the same measure, then you would say the measure of segment AB equals the measure of segment CD. Notice the notation. If you're talking objects, it's congruent. If you're talking measures, it's equals. And remember with if and only if, it could go the other way around. You could say if measure of AB equals the measure of segment CD, then the two segments are congruent. So refer to this cheat sheet as needed. We are going to ask some specific questions about cheat sheet 2 and 3. I don't believe you'll need cheat sheet 1 on these. First question, name the property illustrated by the statement. And you should have this already on a handout so you don't have to write everything down, but if needed, pause it, write it down. If angle R is congruent to angle T, and angle T is congruent to angle P, then angle R is congruent to angle P. If R and T are congruent, and T and P are congruent, then why is R congruent to P? We have that. Go ahead and take a look at cheat sheet 2. Go find it. Get good at this. Know that you'll use that often. I know it's written really small here. You can blow it up. If A and B are equal, and B and C are equal, then A and C are equal. They're both equal to the same number in this case. It works with segments, it works with angles, you can use it for equals, you can use it for congruent. Therefore, this is the transitive property. And you can't just write transitive because it says name the property. It's actually called the transitive property. And you can't spell it wrong. I don't grade spelling, I do grade copying. Copy that from your cheat sheet. Be a good cheater. You don't hear that from your teachers very often, do you? Next one. If segment NK is congruent to segment BD, then segment BD is congruent to segment NK. Pause it. Go find it. Don't cheat and just wait for me to start. Go find it on your own and see why you can take segment NK and BD and switch the order of them. Exact same statement, order is reversed. That is the symmetric property. And this is the easiest one of all, but the most common one for people to make a mistake on. Anything is congruent to itself. Anything is equal to itself. Go look it up. Pause. Go find it. All right, you're back. Anything is congruent to itself. Make sure you spell it right. It is the reflexive property. Practicing my perfect cursive. Don't do that very often. The reflexive property. Anything is congruent to itself or anything is equal to itself. How about if angle Q is congruent to angle V, then angle V is congruent to angle Q. Yep, we've already used this one, but we used it in part B as a congruent segments. This time we're using it with congruent angles. Doesn't matter, it still is the symmetric property. Other way around. This time they're going to give you part of the statement and tell you what you have to use. In this case, the reflexive property. You have to fill in the blanks. Go look up reflexive property. Find out what it is. Actually, that's wrong. I wanted symmetric property in this one. Symmetric property. If angle W is congruent to angle D, then angle D is congruent to angle W. Reflexive allows you to reverse the order. Reflexive property actually wouldn't even work in that one because we already have it congruent to something else. Try this one. If segment HG is congruent to segment JK and segment JK is congruent to segment LM, then what's true using the transitive property? If this person or segment is congruent to this segment, which in turn is also congruent to the following segment. Transitive property says, since they're both congruent to the same segment, then they must be congruent to each other. Keep it in order. Start with segment HG, finish with segment LM. You can't reverse those orders because that would be a combination of symmetric property. Keep it in order. If the first one is congruent to the second and the second is congruent to the third, then you have to take the first congruent to the third in order. Don't forget your segment bars. Don't forget your angle marks or you're going to get marked wrong for notation. Next one, if this is congruent to that, then angle B is congruent to angle C. If this is congruent to that, then angle B is congruent to angle C. Symmetric property again, angle C is congruent to angle B. Then angle B is congruent to angle C. How about this one? If the measure of angle Q equals 30 degrees, and the measure of angle V equals the measure of angle Q, then the measure of angle V, notice they're using equal signs every time because we're talking about the measure of the angles. They want you to use the substitution property. We have two equal angles. They're the same. They're equivalent. They're the same size. They're the same shape. They're the same whatever. They are exactly the same. We want the measure of angle V. The measure of angle V. So we took this original statement, if measure of angle Q equals 30, and we took that measure of angle Q out of there. Said, nope, we're not asking about the measure of angle Q, we're asking about the measure of angle V. Since those are equal properties, we're going to take that measure of angle V and put it in its place. We're going to replace measure of angle Q, put measure of angle V in its place. A substitution, just like there'd be a substitution in a game, an athletic event, and a teacher, a substitute teacher. Replace it, then the measure of angle V equals 30 degrees. Substitution property. So let's go back up to the one that I screwed up with the reflexive property. When would we use the reflexive property? What would that look like? Maybe if it said the measure, no, we'll use it, just an angle. Angle B is congruent. How do you do the reflexive property with that? Angle B is congruent to angle B. Maybe add that one on your notes since I goofed one up. All right, and finally, solve for x using the given information, but you have to explain your reason. Hopefully you do have your handouts, you don't have to draw all this, but if not, go ahead and sketch it down. They're telling you that angle W is congruent to angle Z. We're going to solve for x, and we're going to say 11x minus 8 is equal to 9x plus 4. Solve it. Actually, let me move this up here. Solve it. Minus your 9x over here. You get 2x. Add your 8 this direction. You get equals 12. Divide by 2 on both sides. X equals 6. You can check your answer. 66 minus 8 is 58. 9 times 6 is 54. 54 plus 4 is 58. Okay? Found x. Explain your reason. Now this is where it gets a little tricky. You have to use either a definition or a property from cheat sheets 2 and 3. If we turn our given statement into an if two angles are congruent, then if two angles are congruent, then they have the same measure. What did we do? We took the measure of this angle, 11x minus 8, set it equal to the measure of that angle. If two angles are congruent, then they have the same measure. So our reason, you have to write definition, and I'll let you abbreviate definition, of congruent. All of these on cheat sheet 2, you'll write definition of whatever is underlined. So that's our reason for the first one. Let's try the second one. Segment FG is congruent to segment FJ. Segment FG, so this 5x minus 7, is congruent to segment FJ. Segment FJ is also congruent to segment JH. Well, if we want to find how big x is, we have to know something about FG compared to segment JH. It doesn't say anything up here, but it kind of does. If FG is congruent to FJ and FJ is congruent to segment JH, then segment FG is congruent to segment JH by the transitive property. So the transitive property allows us to set this up. Transitive property, and then of course the definition of congruent would let us say, all right, then 5x minus 7 equals 3x minus 1, because if two segments are congruent, then they have the same measure. But transitive property is what we're looking for here on how are we allowed to set this up. So we get 2x, I'm going to add 7 to both sides, 2x equals 6. Divide by 2 and you get x equals 3. Check your answer. 5 times 3 is 15. 15 minus 7 is 8. 3 times 3 is 9. 9 minus 1 is also 8. Couple more. Same thing, solve for x, explain your reason. This time they tell you angle ABD is congruent to angle DBE. Angle EBC is also congruent to angle DBE. Okay, not written in the same order. Doesn't necessarily mean it's wrong. ABD, angle ABD, is congruent to angle DBE. But angle EBC is also congruent to angle DBE. Normally you see this in the reverse order. You see the angle DBEs next to each other. Doesn't matter, it's still the transitive property. As long as you have two angles congruent to the same angle, it is the transitive property. Once you know that angle ABD is congruent to angle EBC, you can then set up the problem. Do the math again. I'll shorten this a little bit. 3x equals 15 and x equals 5. Always plug it in to check your answer. 14 times 5 minus 10 is 60. 11 times 5 plus 5 is also 60. Notice I haven't skipped that step yet. I've plugged it in and checked my answer every time. Last diagram. P is a midpoint of segment KN. KP, the measure of segment KP, equals 18. P is a midpoint of segment KN. The measure of segment KP equals 18. They practically told you what you're going to use. There's given information there. If we turn this into a conditional statement instead of biconditional, if a point is a midpoint, okay, we have a midpoint, then it divides a segment into two congruent segments. What are our two congruent segments? KP is congruent to PN. Segment KP is congruent to segment PN by the definition of midpoint. And the definition of midpoint says that those two are congruent, and we don't need to say it here, but by the definition of congruent, if two segments are congruent, then they have the same measure. You get 7x equals 28 and x equals 4. 7 times 4 is 28. 28 minus 10 is 18. And it does say on all of these to find x. It didn't say find the measure of the angle or find the measure of the segment. It just said find x. So on all of them, you're finding x. All right, that's what you're going to be expected to do in your assignment, to be able to not only set up the equations, and obviously they're very nice, simple algebra to work with because we're focusing more on the geometry than we are on the algebra, but don't make a mistake on the algebra and get the problem wrong when I want to focus on, can you come up with the reason used for this? All right, that's section 2.6. Good luck.